So let f of x be the square root of x minus 1 and g of x be x squared plus 1. We want the domain and range of each function. Don't forget that we have the calculator. And maybe you know these already, but if you don't, you can always draw them if it's on the calculator paper. So we've got the root of x minus 1. So let's just graph that one. So it starts from here and continues to go upwards, and we can see that because it's just root x translated 1 unit to the right, so we didn't really need the graph. So if we look at f of x, then we can say that the domain is all real values greater than or equal to 1. If we then look at the range, y is real, and we can see it goes from 0 upwards. So y is greater than or equal to 0. Now let's consider g of x. So we want the domain and the range for that. Now we could plot that as well. So let's just get rid of that, and we have x bracket x squared add 1, and let's graph that, and we can see no reason why the domain should not be all reals. And just from the graph I can see that's going down forever, that's going up forever. So we would have y is all reals. Now we want to find g of f of x, simplifying fully. Well, that's going to be g of root x minus 1. So what we need to do is put root x minus 1 where x is in here. So that's root x minus 1, and then we have root x minus 1 squared add 1. Well, if we square a square root, we just undo it. So it's going to be x minus 1 add 1, which is just x. So it's going to be x root x minus 1. We now want to state the natural domain so that g of f of x exists and find the corresponding range. So g of f of x is this. So if we look at the domain, it's just going to be like f of x. We can't have a negative under the square root, so we're going to have x is a real, x is greater than or equal to 1. Now what about the range? Well, we know what the root x minus 1 does. In actual fact, let's not worry too much about it because we have the calculator, and a graph really helps. So we've got x root x minus 1, and let's graph that, see what happens. Well, it seems to come from here and just go upwards. So y is a real, y is greater than or equal to 0. Now, could we have seen that if it was non-calc? Well, yes, we could have done, because we know that it has to start at 1 and go upwards. And then just think about substituting 1 into here, 1 times 0, so that would put us here. And then as x increases, clearly this is always positive, and since we started here at 1, this one's always positive, so it can only really go upwards.